In 1935, Charles Richter defined the magnitude m of an earthquake by the equation m equals log to the base 10 of A over S, where A is the amplitude in centimeters of the wave recorded on a seismogram, and S is the amplitude in centimeters of a standard earthquake. What is the magnitude of a standard earthquake on the Richter scale? So we have to plug in for A. A is the amplitude in centimeters of a wave recorded on a seismogram. So A is equal to S, whatever S is. S is the amplitude of a standard earthquake. We don't know what the value for S is, but we're plugging in for A. We're always dividing the amplitude of the earthquake measured by the amplitude of the standard earthquake. So we plug S in for A, and we can then calculate M. So M is log to the base 10 of S divided by S. Well, that's log to the base 10 of 1. So 10 to the power of what number gives us 1? Well, if we raise any number to the power of 0, we get 1. So m must equal 0. So even without knowing what S is, we now know that the magnitude of a standard earthquake on the Richter scale is 0. The famous San Francisco earthquake in 1906 registered a magnitude of 8.3 on the Richter scale. In the same year, another earthquake in South America registered an amplitude 4 times that of the San Francisco earthquake on a seismogram. Find the magnitude of the South American earthquake on the Richter scale to 1 decimal place. For the San Francisco earthquake, let the amplitude equal A. We know what the magnitude is. The magnitude is 8.3. So when we plug A in for A, we just get log to the base 10 of A over S. But this must work out to be 8.3. So we don't know the amplitude A. Now for South America, we know that the amplitude is 4 times that of the San Francisco earthquake. So it's 4 times A. So now we want the magnitude of the South American earthquake. So we plug 4A in for A. We get log to the base 10 of 4A divided by S, and we have to work out what this is, given that we know log to the base 10 of A over S is 8.3. So we have to somehow try to write this here in terms of what we have up here, because we know this is 8.3. Now we can use one of our laws of logs to rewrite this thing here as log to the base 10 of 4 plus log to the base 10 of A over S, because we have a product here. We have 4 times A over S. The log of a product gives us the sum of the logs of the factors of the product. So the factors are 4 and A over S. So we have log of 4 plus log of A over S. Now we'll have to calculate log to the base 10 of 4. But we know what this thing here is. We know that this thing is 8.3. You can calculate log to the base 10 of 4 on your calculator. Calculators come with a log to the base 10 button. That's what log stands for. The base is 10. Okay, so we get 0.6. In other words, 10 to the power of 0.6 gives us roughly 4. Now I will write this down to 3 decimal places, so we have 0.602 plus this thing here, which is 8.3. Okay, we can write this down to 1 decimal place. To 1 decimal place we get 8.9. So the magnitude of the South American earthquake was 8.9 on the Richter scale. An Irish Times article on 27th of June 2012 was headed "Mayo Earthquake Surprises Geologists." This referred to a magnitude 4 earthquake off the coast of Mayo. What is the amplitude of the San Francisco earthquake compared to the Mayo earthquake to the nearest whole number? Now when we have to compare these amplitudes, it means we're going to get the ratio of the amplitudes. That's better than getting the difference in the amplitudes. So from part B, the San Francisco earthquake had a magnitude of 8.3. And we're given here that the Mayo earthquake has a magnitude of 4. Remember, we don't know the amplitude of the San Francisco earthquake. We know that whatever A is, when we work this thing out, we get 8.3. For Mayo, we have 4 equals log to the base 10 of the amplitude of the Mayo earthquake, which I'll call AM, divided by S. Now we want the amplitude of the San Francisco earthquake A divided by the amplitude of the Mayo earthquake AM. We want to get this ratio. Okay, we can use our property of logs to rewrite this equation as a power equation. We take the base, which is 10, raise it to the power of 8.3, and we get the argument of this log function, which is a over s. So 10 to the power of 8.3 is a over s. Do the same here. We put 10 to the power of 4 equal to the argument of this log function, which is am over s. Now we can see that s is common to both of these equations, so we should try and make s the subject of both of them, or we could make s the subject of one of them and plug into the other one, whichever. Okay, I'll make s the subject of this one here. So we just rearrange this equation and we get s equals a divided by 10 to the power of 8.3. Basically we can just interchange s and 10 to the power of 8.3. You get that from cross multiplying. A times 1 is s times 10 to the power of 8.3, and rearrange then to get this. And now we can plug this thing in for s. We can do it this way, and we can get a relationship then between a and am. So this is what we get. We plug in for s, we get this thing here. Now I can multiply above and below this fraction by 10 to the power of 8.3. So this is what I get on the left hand side, and then I can divide across by 10 to the power of 8.3, divide both sides to get this. So now I have the ratio am is to a. Of course earlier I said I wanted to get a is to am, but whichever, it doesn't matter. Well, maybe this might tell us a bit more. Well, it's a bit clearer to see, I suppose. Put the larger amplitude over the smaller one. So the amplitude of the San Francisco earthquake is 10 to the power of 8.3, divided by the amplitude of the Mayo earthquake, which is 10 to the power of 4. So that's going to give us 10 to the power of 8.3 minus 4. That's 10 to the power of 4.3. So the amplitude of the San Francisco earthquake is 10 to the power of 4.3 times greater than the amplitude of the Mayo earthquake. So A stands for the amplitude of the San Francisco earthquake. So I'll write down just what I said. 10 to the power of 4.3 is more than 10,000, of course. 10 to the power of 4.3. You can see it's close to 20,000 times. So the amplitude of the San Francisco earthquake is almost 20,000 times the amplitude of the Mayo earthquake. Actually, we want this number to the nearest whole number, so this is going to be 19953. So I'll write in SF to make it clear we're talking about the amplitude of the San Francisco earthquake. It's 19,953 times the amplitude of the Mayo earthquake. Mercalli in 1906 produced another scale based on human experience, now known as the modified Mercalli scale. Use the table shown to find the percentage change in amplitude on the Richter scale for earthquakes measuring 9 on the Mercalli scale, from the lowest to the highest magnitude. Now, the lowest magnitude for an earthquake registered 9 on this scale is this value here. Just project across here. This value here is 5.9. And as you can see, this value here is 6.5. So this scale here is the magnitude, Richter magnitude scale. So we can use this formula here to relate the magnitude of an earthquake to its amplitude. So if m is 5.9, I'm going to call the amplitude AL. You could say L for the lowest value of the magnitude for a category 9 earthquake. And when the magnitude is 6.5, I let the amplitude be AH. I suppose H for the highest value that a 9 earthquake can have. And we want to find a relation between AL and AH. So, you know, we rearrange these log equations, write them as power equations. So we can see that AL divided by S is going to be 10 to the power of 5.9. And similarly here, AH divided by S is going to be 10 to the power of 6.5. Now I'll take the larger value and divide it by the smaller one. So I'll take AH over S and divide it by this, and the S's will cancel. But that'll be the same as dividing this number by this number. So we have AH over S divided by AL over S, and that equals 10 to the power of 6.5 divided by 10 to the power of 5.9. So I'm just taking this equation here and dividing both sides of it by AL over S, but AL over S is equal to this. So I'm dividing both sides of this by the same thing. And if we multiply above and below by S in this fraction, the S's cancel out. So now we can see that the ratio of the highest amplitude to the lowest amplitude is 10 to the power of 6.5 minus 5.9. That's 10 to the power of 0.6. So you can see we have to increase the amplitude of AL by a certain percentage. Well, to get AH, we have to multiply 10 to the power of 0.6 by AL. Now let's get 10 to the power of 0.6. We see that it's 3.98. So we have to multiply the amplitude AL by 3.98 to get the amplitude of an earthquake of magnitude 6.5. So we have to increase AL by 398%. So just to remind you, an earthquake of magnitude 6.5 has an amplitude that is 3.98 times the amplitude of an earthquake of magnitude 5.9. In other words, we have to increase an earthquake of magnitude 5.9. We have to increase its amplitude by 398%. So I just multiply this by 100 and I've rounded to the nearest integer. If the standard earthquake gives an amplitude of 10 to the minus 4 centimeters on the seismograph, what is the reading for a Mercalli earthquake reading between 9 and 10 to the nearest centimeter? Now we know that the letter S stands for the amplitude of a standard earthquake. So S we're given here is 10 to the minus 4, so we now know what the value of S is. So now, if we know what the magnitude is, we can get the amplitude. So the magnitude runs from 5.9 to 6.5. So the smallest value of M is 5.9, the largest value is 6.5. So let's start with the value 5.9 for M. So we just use this equation, replace M with 5.9, and we have to solve to find the corresponding amplitude, which I'll call A. See, we know S now, so there's only one unknown. 10 to the power of 5.9 equals A divided by 10 to the power of minus 4. So to find A, we just multiply 10 to the power of 5.9 by 10 to the power of minus 4. So we add the powers, 5.9 plus minus 4. That gives us 10 to the power of 1.9. And, okay, amplitude is measured in centimeters. So this is the amplitude of an earthquake of magnitude 5.9. So that's the amplitude of the smallest earthquake of type 9 on the Mercalli scale. Next we get the amplitude for an earthquake of magnitude 6.5. That's the largest earthquake of type 9 on the Mercalli scale. So we set M equal to 6.5, and we just do the same. So this is what we get. We find the amplitude is 10 to the power of 2.5. So earthquakes of type 9 on the Mercalli scale range in amplitude from 10 to the power of 1.9 centimeters to 10 to the power of 2.5 centimeters. The energy E in joules released in an earthquake is given by E equals 1.74 by 10 to the power of 5 plus 1.44 m, where m is its magnitude on the Richter scale. The atomic bomb dropped in Hiroshima produced a reading of magnitude 4.3 on the Richter scale. How much energy did it release? So all we have to do here is plug in 4.3 for m. Just calculate this. Now I've rounded this number to the nearest integer. We get 270,738,000,019,899 joules.